All right. Good morning, everybody. So we left off yesterday right here. So we're talking about the division by a complex number and the idea, because it's weird to try to make sense of dividing by a complex number, is that we basically try to, like our goal, maybe I should write that. Our goal is to rewrite so I is not in the divisor or denominator, since we're writing these things, as fractions basically. Is that off the? Yes, it is. Sorry. So we want to rewrite this thing so that the imaginary part only shows up in the numerator. Again, we're still kind of, you went and did it, I guess. So now you kind of see why the thing that we did works, why we did that. But again, I kind of, just said, trust me on this one for a second, for multiplying by this thing in orange that we call the complex conjugate. Again, looking at the denominator, which is 2.2 plus 3i, multiplied by 2 minus 3i, for reasons that will become clear in a second if they aren't already. And then because we're rewriting a fraction as a different kind of fraction, we do it on top and bottom, so we're not changing anything, right? So we're just multiplying by 1. So we did the multiplication. You've got 12 minus 18i over all of that. And what happens? Minus 6i plus 6i cancels, right? That's 0. What else? There's an I squared, right? I squared is the same thing as -1. So this becomes, not messing with the stuff in the numerator, just bringing that over, 12 minus 18i over 4 minus 9 times -1. Okay, well, that becomes 12 minus 18i over 4 plus 9, which is 13. Now, sorry. Now the whole thing, the whole issue that we had, kind of the difficulty conceptually yesterday was, I don't know what it means to divide by an imaginary number, right? Now we've rewritten this thing. All we've done is multiply by 1, right? Just a specific way of writing 1. But we did that. We simplified some stuff, and look where we are now. 12 minus 18i. Okay, the numerator is still a complex number, right? So it's still got its own thing. But what we're doing now is dividing by 13. Well, I might still have some difficulty with kind of fully understanding what that complex number means. But I can imagine taking a thing and cutting it into 13 pieces, right? So what we've done is change this from a place where I don't even know how to conceptualize what the division means, to a thing where, well, no, okay, whatever this thing is, cut it up into 13 equal pieces, right? So that's the answer. That's the result. That's what you get when you divide 6 by whatever it was, 2 plus 3i, is you get this. And then last thing we would do is just for the sake of kind of putting this thing in a little bit nicer form, separate the real and the imaginary parts. And then because we've got some fractions here, if you could reduce, you would reduce. Neither of those do, but just separating out the real part from the imaginary part. Okay, questions about that?
Yeah, if we were to leave it like that at the top on a test or something, would we get marked wrong?
So generally, something like this on a test, I'm going to say in the directions write it in standard form, A plus BI. So I would want to see that. Now it's going to be 1 point out of 10 or something, so not a huge deal. I'm pretty sure I meant to go back and check, but I forgot this morning. I'm pretty sure my math lab's going to want to
like this, separated out. So by the time you go through the homework and stuff, you'll be, kind of used to doing it like that anyway. Yeah, okay. So
Y'all tell me 10. What do we need to multiply this by to, sort of get the ball rolling, to start the process? 2 plus I. How do we know? Yeah. Switch the sign, and the thing that you pay attention to is the denominator, because again, the thing that's, that we're trying to avoid is having to divide by a complex number, right? So we're trying to get I out of the denominator. That means I need to focus on the denominator to, sort of start setting things up. So 2 plus I, if you do it there, you got to do it top and bottom. And then go from there. Okay, so today we have, sort of talked about all the stuff that we need to, like you have all the tools. Today we're going to work some problems. So grab your notes. Hopefully you still have. There are those 2 at the bottom that hopefully you've already done because I asked you to. And then the last 2 pages are just a whole bunch of practice problems. There are top of page 3, 11 through 14. There are 4 quadratics to solve. Kind of all the stuff you're ever going to know about solving quadratics at this point. You know how to factor or use square root thing or use quadratic formula or complete the square if you want it, I guess. You've got a full set of tools for doing that. These may end up having, nice solutions. They may end up having solutions that are not so nice. They might be complex now, but work them. The rest of page 3 has some quadratic inequalities. The way we're going to solve inequalities is exactly the same as we solved inequalities before. I gave you kind of a reminder of that, but solve the equation first. So forget about less than, greater than, whatever. Just set equal to and solve. So again, that's going to be solving a quadratic factor, quadratic formula, whatever. Solve that. And then similar to what we did with absolute value stuff, put those on the number line and test around them. You can test around them thinking about the graph because we know that it's a parabola opening either up or down. You can tell that kind of at a glance, right? So you're just checking for, once I get solutions to this, the zeros, the x-intercepts, I'm just checking for where it's negative. Well, for example, I know that this one opens up. So if it crosses the x-axis twice, it's going to be negative between those 2 solutions, right? Because that's where it sits underneath. But, just set it up and test somehow graphically or plugging in points. And then the last page has a couple of application problems. So like I said, we have no other agenda today but to work problems. So a lot of you have already moved furniture around. The rest of you guys get in the group so you talk to each other. You guys in the middle, there's like 7 of you. I don't know if you want to disperse or how you want to do that, but work problems, ask questions as they come up. I'll walk around and pop in from time to time. And then we'll, if there's stuff that we need to talk about all as a group, we can do that too. One of those inequality problems for a minute. I don't remember what number that is. It's the first one in the inequality section, but x squared plus 6x plus 8 is less than 0. Now, again, first thing I'm going to do is solve the equation because the inequality is, well, if you're not careful, it can sort of mislead you if you try to do it with a less than. So x squared plus 6x plus 8 equals 0. You go solve that either by factoring or quadratic formula or whatever. You get x equals -2 and -4, right? So factor or quadratic formula. I'm going to leave that part out because you can handle that part, right? -2 and -4. What that means is that this, what kind of thing is this if I think about it as a function? Quadratic, so it's a parabola opening which way? This quadratic, it opens up. This parabola, it opens up, crosses the x-axis at -2 and a -4, right? We got 2 real solutions. Those are real x-intercepts, places where the graph crosses the x-axis. So I'm going to draw out a number line again to sort of help like organize my thinking, right? Keep track of stuff. I'm going to mark -4 and -2. That's the x-axis. Except I didn't fit it all on the screen. There we go. And then what we're looking at is, again, a parabola that's opening up, right? So the graph looks something like that. Now, either by thinking about the graph or by testing points, we can figure out how to answer the inequality. Right? The inequality says that we want to know where x squared plus 6x plus 8 is less than 0, smaller than 0. So where would that be here? Is it less than 0 on this piece? The function values, the y values? If this is the x-axis, are the y values here above or below the x-axis? Above, right? Which means they're positive. So it doesn't work here. What about here in between them? Yeah, because it's sitting below the x-axis, right? So the y values are negative. So this piece is a keeper, this middle piece, that solves the inequality. What about out here? No, because it's sitting above it, right? Or if you prefer, you can do the thing where you test points, right? -5 maybe, and -3 and 0. If you plug those in, so for example, like if x equals 0, 0 squared plus 6 times 0 plus 8, that's 8. Is 8 less than 0? No. Similarly, it's not going to work out there, but it does work in between here. So we're not doing anything different than where we've done inequalities in the past. You may need to go back and review that and get some more practice with it. But either graphically or by testing points, whichever version makes more sense to you, determine each of these 1, 2, 3 intervals whether to keep or toss it. Right? Does it make the inequality true or not? The only place where it's true is this stuff here in the middle. So our solution set looks like everything between -4 and -2. Should we keep the endpoints or not? Open or close, parentheses or brackets? Open because it's not equal to, right? Strictly less than. So because this is strictly less than, my solution set is going to look like this, the open interval from there to there. Write that in interval notation. It's everything from -4 to -2. Open at both ends. Okay, so we solved the equation first. Again, factoring, quadratic formula, whatever it means to solve that particular equation or whatever you're more comfortable with. I get -2 and -4. Those are not the answers, but those are sort of the key to finding the answers, right? Those are the endpoints where things change. Then we got to test, well, there were 2, or if there were 2 solutions, that means there are 1, 2, 3 intervals that we need to check, right? And you can check them either by thinking about the graph or by plugging in test points, and then just write down the stuff that actually works. Okay. All right, give another one a shot then.
so, you're right, maybe. Maybe something more for one. So maybe like, check it out. Okay. One of the two are actually. There's a few things, it's like 0 and there's. Like those are in between. Versus the opposite. Oh, you dropped it. Okay, so you dropped the negative something. So that should be negative 13. It should all- And I think the way to think about it is it's like that, like maybe even draw it in, draw the graph in or something and show me that you're checking. Just so that, like when I go back and or when I go to like the grade stuff, I can tell like where your answer came from. It's not just like. Kind of. Okay. Yeah, that's fine. Yeah, you just want to know like how big it is, so that if you're gonna like, or test, or you just know like. Yeah, no, that's. Yeah. Yeah, or if thinking about the graph works for you, you're just gonna get some graph over it. Right, so you want to know this. So, yeah. Okay. Yeah, negative 13. Right? So. So that's a little bit. So. That's one. Or like I said, like if the graph and then where it's. If that makes sense to you, that's perfectly fine.
I would know, but
Just,
yeah,
you know, like draw my picture or something, it just shows me that. This is my discount. Yeah.
So to solve this one, we have to.
Yeah.
It does
factor. So. What you look for is things that multiply A times C. And add. So 30.
So it'd be X plus.
So 10 and 3. To get the. see what the factors actually look like. Once you come up with 10 and 3, usually just split that term up. Because it's not x plus 10 and x plus 3, because the first product there will give you 3x squared. So one of them's got to be 3x. So do this, and then try to think about like the first average and the last. What are the factors? So 3x squared. So something like that. Or you can try to do a factor between thing, like look for a common factor here. And a common factor here. But that's. So, the first part, you get 3x squared. Has to be 3x. And then if that's the outer part of the product. Inner part of the product. Last part is and then yes.
Thank you. Okay.
All right, y'all. So go and do math. Remember, solutions to all of that stuff is the Blackboard. Everybody seems to have plenty of stuff to keep them busy. But solutions to all that stuff are in Blackboard, so you can check things. You have everything you need to do homework for 3.1 and 3.3. I would suggest go ahead and knock that stuff out. Thursday, Friday, we'll start the chapter 4 stuff. It would be helpful if you have a good, solid foundation of this stuff before we move on. So,
All right, y'all have a good day. I'll see you on Thursday. Let me know if I can